Okay, so we've been looking obviously at right angle triangles, and we've been using the SOHCAHTOA formulas. And now, and the last one we did a little bit of practical or application questions where they had words in it. So sometimes when we get the wording question, they're going to use they're going to say the wording of elevation and depression, and that's going to do with describing the angle. Okay, so describing, if you wrote that, describing the angle, and just maybe put in brackets because we use that symbol theta as the angle. So we're going to be doing that. So angles of elevation, when they say there's an angle of elevation, so we're going to refer to this horizontal line, okay? So maybe just on this diagram, I want you to write that is the horizontal line. Sometimes, like if you forget, they say, because when you say the horizon, like how the sun comes up on the horizon. So there you go, that's a horizontal line, okay? So sometimes if you get a bit confused. So the angle of elevation is measured from that horizontal line to the line of sight. So say we have this man here, and he's looking up at the balloon. So his line of sight is like that there. So the angle of elevation, you can see, is when you go from the horizontal up to that, up to the line of sight. So if you look there, can you see we can sort of create a right angle triangle, couldn't we? Yeah? And the line of sight, what side of the triangle would the line of sight be? It would be the what do we call the one opposite that? It's the hypotenuse, okay? All right, so that's what we're going to do. So let's have a look, and we'll do an example question here. So that's elevation. Elevation is when you're looking up at it. Okay, so a park ranger measured the top of a plume. So a plume is like the volcanic ash bit, so you can sort of see in the diagram, to be the angle of elevation of 29. So you can see here, there's the 29. So just maybe write on these notes again, just so we're getting used to, write that is the horizontal. Okay, so remember we get our notes in our thing, so we can always, and that is maybe we'll write the line of sight. Okay, so from her map, she noted that the volcano was 8 kilometres away. So they're saying here, along there. And she calculated the height of the plume to be 4.4. So I think what they're saying there is this side is 4.4 kilometres. Show how she might have done this. Give that to your correct to one decimal answer. So here they're sort of saying that this is the question. They want to check that she's correct. So what you do when you get these worded problems and you've got a bit of a diagram like with pictures in there, let's just simplify what we have in just a normal triangle. So we know that this is 8 kilometres and we know this is 29, and they want me to check this side here. Okay, so let's label it up now, just like our normal triangle. So what side is the X if we're thinking about SOHCAHTOA? So what side is X in terms of good, O. And what side is the 8 kilometres? Adjacent. So which one has O and A in it? Good, so we'll write tan theta equals O over A. Then we substitute in what we know, and then obviously we can do solve in our calc. So in the blue is what you need written in your books, and then we're just going to solve that, and we need to make sure our calculator is on what? Good. Okay, so when I get that, I got 4.43, so she is correct, isn't she? So the range is correct. So check it to one decimal place. So we would say, yeah, X equals 4.4. That is correct, kilometres. So now we're going to look at elevation of depression. So that's when you're sort of looking down on something. So here again, we're going to have this horizontal line, and you're going to have your person who's thing. So make sure you put in here again. Let's label this is the horizontal line. So angles of elevation and depression are measured from that horizontal line. Okay, so you can see the depression, we're looking down there. There's the angle of depression. And you look down, and here is the line of sight. Okay, so line of sight there. So depression's when you're looking down. Now you can see we can make a right angle triangle when you join it up like that. So that's how we're going to be able to do that. Okay, so let's do this next question. Now, this diagram looks confusing to me, so I'm going to draw a diagram if I got this question without the diagram and show you how we do it. So from a cliff 61 meters tall, so I normally just like, all right, I've got a cliff, and I know this is 61. Okay, above sea level, so you know then you've down here you've got the sea. Okay, this Chen saw a capsized yacht. Okay, so he saw this yacht upside down. There you go. Okay, and we got little Chen up here. All right, so he saw this, he estimated the angle of depression was about 10 degrees. So you got to go from Zen's horizontal. So remember, it's always the horizontal line. And then his line of sight. So his line of sight would be from him down to the yacht. Okay, so when they say he estimates the angle of depression is 10 degrees, it's this angle in here that's 10 degrees. So then they say how far is the yacht from the base of the cliff. So they pretty much want this as the question, yeah, this distance here. Okay, so if you look, what we might use, instead I'm going to use the triangle, like I could use this triangle up the top. So I'm going to do it like that. Okay, now this bit here that I've just drawn is the same as the cliff distance. Would you agree? So I can say that's 61, and I've got the angle of depression is 10 degrees. And now would you agree that this distance is the same as that horizontal line up there? So I can say that's my x. So you can draw it like that if you like. All right, so now let's label this. What side is the 61 meters? Good, sorry. And then what's this one? Adjacent. So we're doing tan again. So tan angle equals O over A. So tan 10 equals 61 over x. And then you can do solve, and we're just gonna, you don't have to write the solve, that's why I'm changing it to the green. We're just gonna find out what that equals. Boy, I got it to be 3, now did it say to the nearest meter? So that will be the whole number. So I got 346 meters. So what we can also say is that you can say that the angle of depression in a scenario equals the angle of elevation. So what we mean by that is here, if you look, here's our horizontal line for depression, and here's our horizontal line for elevation. So if you think about just maybe that scenario before, so what we're saying is when we said before, we said if Chen was looking down at, we had the boat, so I'll just draw a little boat in here, and we had the guy up here. So he was looking down at an angle of depression of 10 degrees. If he's looking down, then say if the boat was looking up, it's going to be 10 degrees as well. They always match. So what you're looking down at, they look up at it at the same. So sometimes it could have made it easier to just know if we knew that fact, and we could just use, we use the triangle of elevation rather than the triangle of depression. So let's have a look at this example here that we've got. A cable 100 meters long makes an angle of elevation of 41 with the top of the tower. So here is that, let me go through it. So this 100 meter long wire is there, okay? So here's my horizontal line. So just draw that in there so it helps you understand. And when they said the elevation with that one, so there, that's why that's 41. Okay, to the top of the tower. So here is the tower, obviously, top of tower. Okay, so find the height of the tower. So first what we're going to do, so we'll do A over here. Just quickly draw the triangle we want to use. So we just want to use this 100, 41, and H. So let's label it up. I've got the opposite and I've got the hypotenuse. So I'll just write up here, SOHCAHTOA, which one are we using? If we've got O and H, good. So sine theta equals O over H. Then I substitute in. That means we put in what we, H over 100. Then you can do and solve. Solve. And what do we end up? H equaling. Now it said to the nearest meter, so we just go the whole number. Yeah, so I got 65.6, so I'm going to say 66 meters. So there's the height of the tower. Okay, now question B. Find the angle of elevation, and they want you to call it alpha, to the nearest degree that a cable 200 meters long will make. So I'm gonna I'll highlight that. So they've got this 200 meter cable, and they want to know what this angle of elevation is. And they're asking you to call it alpha. So it doesn't matter. Instead of calling it X, they want you to call it alpha. So if you have a look there, what we're going to use, remember, SOHCAHTOA can only be used on a right angle triangle. So I'm going to have to use that big, long right angle triangle. So this is the 200 meters. This is the height of the tower, which you now know is 66. And so if you use their letters that they're using, we're actually using A, B, and D. And they want me to find this angle here, and they're calling it the alpha symbol. So let's just do the same. We'll label it up. We've got opposite over hypotenuse. So we're still using sine. So we'll write our rule out. So sine theta equals O over H. Then we'll substitute in. So sine alpha equals 66 over 200. And then how do we find the inverse? We use the inverse, don't we? So on our calc, we're going to type sine -1, 66 over 200. And that will tell us what alpha is. Okay, so you just have to type in the green, and what does that end up being? All right, so it said to the nearest degree, so that means a whole number in this scenario. So we got 19.2, so we're just going to say 19 degrees like that. All right.